In this video, we'll continue talking about behavioral ecology. We'll move from innate behavior to the next step on the behavioral ladder, and that is learned behavior. Learning is a modification of behavior resulting from past experiences. You'd expect for behavior to get better or more improved as you moved along in life. You'd expect to get stung by less porcupines over time because you figured out that porcupines are not good for you. We have these kinds of behaviors as well, like public speaking is a great example. The more you do that, the more you get better, the more you realize that not everyone in the audience is staring and talking and thinking about you and so forth. You get the idea. This is a higher order brain function than innate behavior because this requires a brain, for one, and it requires some storage of information. And so I put maturation here too because as animals tend to, as they mature and as they grow and develop over time, their behaviors will also be modified based on that. You think of a new puppy that you bring home that is nuts, and then over time that puppy slows down and begins to mature and actions seem more on purpose. Now, there are some things that go along with learning. Habit forming or habituation is one of those. Behaviors that occur even though the organism doesn't realize it is an example of a habit or definition of that. Habits can be good or bad. They can be things that help survival. They can be things that possibly hurt survival. If an animal has formed a habit of eating food off someone's front porch, this could be a bad habit if that person decided to all of a sudden prohibit eating food off the front porch. And so we get the idea here. Another type of learned behavior is something called imprinting. And imprinting happens at a very crucial point of development, usually early on. This is a time sensitive thing. There's a window of time, so to speak, in which this type of behavior can occur. And then once it's learned, it is a permanent kind of thing. Uh, Birds learning to migrate is a great example of this. Ducks imprinting upon their mother is a great example of this and following their mother around. Why is it good to follow the mother around? Because the mother's an adult. She has survived. She obviously knows what she's doing. So we should follow her around. Another type of learning is called associative learning. There are two kinds of associative learning. This is learning that is associated with some kind of stimulus. The one that most people are familiar with is called classical conditioning. This has to do with the repetition of a stimulus creating a certain outcome, like Pavlov's dog. They fed the dog, and then when you see this picture, they sounded the tuning fork, and they put the two together, and then you only had to sound the tuning fork, and the dog thought it was going to be fed. We train animals like this all the time. We give them treats when they do good things. Then they do those good things, even though if we don't have a treat or not, because they expect the treat. Along that same lines is called operant conditioning. And the best way to think about this is trial and error. This was made famous by a researcher named Skinner, who had a box with mice. You're probably familiar with the mice in the maze. And the mouse would be put into a wooden box, and then it would push a lever down somewhere in the maze, and when that lever was pushed down, it would reveal cheese. But if the wrong lever was pushed, it would cause the mouse to be shocked and so forth. And so the mouse, over time, learned which lever it should push, and therefore this was this trial and error kind of behavior. Another type of learning is called play, and this could be called game theory as well. Play is a behavior to coordinate and practice movements that are necessary for survival. Think about these two lions play fighting. They're not really fighting, but why are they doing that? Well, it is necessary for lions to fight sometimes, but more than that, it's necessary for lions to fight their prey. And so eventually, this kind of play becomes reality. And so this is kind of the idea of practice makes perfect. And so lions and other predators live this out very commonly. So next, the highest order of this kind of learned behavior is called cognition. Cognitive ethology is the study of this branch of behavior. We typically call this like problem solving. And think of this as something like, say, the room is cold and the door is open. How do I fix the problem of the room being cold? I shut the door. And so this would be like a one-step problem. And so these kinds of behaviors are found in the most complex types of organisms. There are some really basic problem solving, like this, there's kinesis and taxis. Kinesis is just the idea of moving around until you find a better solution or a better situation. Roly-polies will move erratically even until they find a moist area, and then they will kind of hide there. Their movements will slow down. They're not complex enough to move toward the moist area, but they do know when they're in one. Now, moving towards something that is desired is taxis. And so the fish here is moving against the current as opposed to going with the current. That is an on purpose choice in order to get food or get oxygen or whatever it may be. The next level of this would be called landmarking. And this is moving toward a set of signals that are like permanent, like think about like spatial learning, like driving. You know, when we see a stop sign, we stop, or when we see a road sign, we know to turn left there to go home. And so this is seen in some even simple types of animals. Insects will put their nest in an area that they recognize, and they will move to that area each time. If you move the landmark, you can trick them into believing their nest is someplace else, and you see that here. Cognitive mapping is the higher level of this. And this is moving and thinking at the same time. You know, I drive home the same way every day unless there's an issue. If I get to 12th and Sycamore and the cars are backed up 3 streets, then I know that I should turn left earlier in order to avoid that. That is cognitive mapping. I know how to get home through other ways. I know the fastest way, but those other ways will be faster under circumstances. And so this is a very high level kind of thinking and problem solving. Migration fits really closely under this set of parameters because migration is a very high level of learning. And migration involves 3 other smaller ideas, and I've written them down here, and one of them is kind of messed up. Let me fix it. All right. So piloting is just simply knowing the route between 2 places, and it's a short kind of trip. You wouldn't need much to get home in this way. If you think about flying a drone, most of us could fly a drone from our homes to the school without any problem, without road signs or anything else. Orientation is the idea of knowing the general whereabouts of a place and following a set of larger symbols. Like I know if I want to go to Florida, I need to go south, and I generally know how to do that by looking at my surroundings. The sun sets in a certain place and yada yada yada. You get the idea. Animals will use these landmarks as well, like the stars and the sun and the wind direction. Putting all of this together, piloting and orientation, is what we call navigation. And this is like recognizing certain landmarks and then orienting yourself based on those landmarks. And so it's a mix of the two. And then the highest level of learning is called consciousness. And consciousness has to do with thinking about one's thoughts. This is something that only humans can do. This is something that we are able to reflect on our own thoughts and talk about them. We are able to change our behaviors based on other things besides a stimulus. We can read a book and think about the behaviors addressed in those books and change our thought patterns based on what we read. And so this is a high level of thinking.